So my dear students, in the previous lecture we have seen about ring counter based on the shift register. Now we are going to look at ring counter based on the counter and the decoder. So now what exactly that we are trying to do is we will take a counter. So we need to look at what is mean by counter. What is counter? The one which counts is counter. What is that is going to count? Counter counts number of clock pulses applied. So we will take a counter. How exactly counter shows the output? The counter will be counting in the sense it will going from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, so on and so forth, based on the number of flip-flops in the counter. Number of flip-flops in the counter. Now if I take a counter which is made up of only 2 flip-flops, say something like this: I have a flip-flop, okay, I have another flip-flop, I am taking output from this, Let us say this is flip-flop A, this is output QA, this is QB, okay. So let us assume that is a synchronous counter, or it can be an asynchronous counter. Let us say this is input to this, okay. Here we are giving a clock, okay. So let us say this is J and K, this is J and K, this is equals to 1, this is equals to 1. When J, K both are 1s, J1, K1, what is the meaning of that? Of course this is clock. J is equals to 1, K is equals to 1, means the output Q is always Q bar of T. What is Q bar of T? Q bar of T is nothing but Q of T plus 1. What is Q of T plus 1? Next state. Next state will be the complement of the present state for both the flip-flops. Let us say this is flip-flop A, let us say this is flip-flop B. Now how exactly QA, QB are going to change? QA, QB, okay. Initially it will be 0, 0, then it will be 0, 1, 1, 0, then 1, 1, right. So what I try to do is, I have my counter outputs which is QA and QB. I will take QA and QB which are outputs from the counter. So what I can do is, I can give that to decoder. This is 2 line to 4 line decoder. So there will be 4 outputs. What are the inputs possible? Is this. Inputs to the decoder can be 0, 0, 0, 1, 1, 0, 1, 1. When 0, 0, this line will be 1, rest of the lines will be zeros, because this is a decoder functionality. It decodes what is being applied. 0, 0 applied means 0, 0's line will be 1, because active high outputs. For 0, 1, now how exactly output will be 0, 1, 0, 0. For 1, 0, 0, 0, 1, 0. Okay. For 1, 1, output will be 0, 0, 0, then 1. Now if you see this, whatever we are getting over here are similar to, let's suppose if I repeat this sequence, after 1, 1 if I give 0, 0, once again I will get this as an output. I have started with this being the output, I got this output, I got this output, I got this output. Once this is done, then I am getting this same output once again. Cycle repeats. Okay. Is it not the same thing that we have seen with respect to ABCD output waveforms? A is 1, then 3 zeros. Now what about B? Let's say these are A, B, C, like if you look at the outputs and if you observe, if you plot the graph, so it will be 0, then it will be 1, then it will go 0, then it will be 1, then it will go 0. So in a particular sequence, okay, the particular sequence, okay, we are able to generate it. This way of generating a particular sequence is nothing but a control signal, okay, generation. Using what? Using ring counter. This is how we can generate the control signals by using counter and decoder. I have explained here how counter works. Now we are taking the counter outputs as input to the next. So what is the complete diagram? The complete diagram is like this. I have a 2-bit counter, which is 2-bit counter. What is the input to the 2-bit counter? Just I am giving a clock to the 2-bit counter. What I am getting? I am getting 2 outputs. This is nothing but whatever the outputs that I am getting will be the inputs to what? Inputs to decoder. From the decoder I will get 4 output lines. Okay. These are what exactly? Control signals. Okay. Fine. With this we will stop here.